see if we have a solution for an actual system of equations. So let's say we've got the system x plus y equals 6, joined together with the equation. Let's see if we have two x minus 2y equals 4. Just going to freestyle this one. And our question is 4 comma 2 a solution to this system? We're essentially just replicating our process from yesterday 2 times with 2 different equations, but using the same coordinates. It's almost exactly like what we did in our warm-up today. Because it is exactly what we did in our warm-up today. So we're just going to plug our x and y into each equation one at a time. It's like 2 problems in one. But the trick here is we have to get a true statement for both equations if we want that point to be a solution for the system itself. So we plug it into our first equation and we get a yes. Plug it into our second equation and get a no. It's not going to be a solution. Even though it works with one of them, it has to work with both. In our definition of a system, just real quick to go back to yesterday, we said that a system is 2 or more linear equations that are grouped together and related somehow. That relation that we mentioned is that they have one single point on both of these lines. And we'll see kind of graphically what that looks like on Thursday. Maybe tomorrow. Well, we won't have time tomorrow. This week at some point. So in this point, 4 comma 2, what's my x coordinate? Is it 4 or is it 2? My x coordinate here. 4. What's my y coordinate? 2. So I'm going to take my first equation here, x plus y equals 6. I'm going to take out my x. I'm going to take out my y. And I'm going to plug in 4 for x, 2 for y. Bless you. just like that. I'm going to zoom this down here. I'm going to do the same thing with my second equation. I'm going to take out the x, take out the y, leave everything else about that equation exactly how it is. What am I going to plug into this first parentheses here? 4. And my second parenthesis? 2. Again, my x and my y. My x and my y. Bless you. So we're using the same point, different equations. Got to get true and true for both of those if we want to say that 4, 2 is a solution to the system itself. So in the first equation, there's nothing to multiply. All we need to do is add. What would 4 plus 2 give us? 6. Bring down the equals 6. Is 6 equal to 6? Yes, it is. So this is true. But again, that doesn't necessarily mean this is a solution. We got to test out the other equation as well. There's definitely some multiplying we've got to get out of the way first before we subtract. So what would 2 times 4 give me on the left? 8. Bring down the minus. What would 2 times 2 give me on the right? 4. Now we can subtract 8 minus 4, and that gives me what? 4. Again, we're bringing down that 4 on the right side of our equation each time. And is 4 equal to 4? Yes, it is. So this is true as well. Even though we get different true statements, 6 is equal to 6, 4 is equal to 4, they're both true. And that's what matters. So we can say yes, 4, 2 is a solution to this system. So our answer here would just be yes. So we're not doing anything different from what we did yesterday. We're just doing it twice. You may be thinking, oh, we have twice the amount of work. Well, we should be a lot better at this now that we've gotten a lot of practice yesterday and we reviewed it today. So hopefully it does go a little bit quicker this time around. Even though, yeah, you do have 2 equations that you got to test out. Let's set up another example. Let's say 3x minus y equals 7. You say true?
No.
Oh, I was like, we don't even know the point yet. We don't know if it's true or false. That's our first equation. 3x minus y is equal to 7.
I'll say sure.
Oh, okay, I got you. And then let's say we've got negative 2x plus 4y That is a 7, yeah. Equals 3. Let's go with that. And we'll ask the question, is 3 comma 2 a solution to this system? I'm going to set up my two equations. 3 times x minus my y equals 7. Negative 2 times my x plus 4 times my y equals 3. So we're splitting this system up, taking a look at each equation one at a time, but we're plugging in the same numbers. What am I going to plug in for x? 3. What am I going to plug in for y? 2. 3, 2, 3, 2. X, y, x, and y. Go ahead and take about 2.5 minutes, work through this on your own or with someone in your group. See if you get a true statement or a false statement for both of them. See if you can make the determination whether this is or is not a solution. Go ahead, let's go 2 minutes, see how we work through that, and then we'll come back together and talk about it. Go ahead. Let's work through it. Work through it? Don't let this distract us. So that we really good so far. Good so far. Oh, I didn't even. When we're done, yeah. Yeah.
If the first solution you did, if it was already false, so you didn't have to solve the other one?
Great question. No. As soon as you know one is false, the whole thing is false. Don't even waste your time worrying about the second one. And you'll see a couple of those on the worksheet today. So it's a great point to bring up. I would totally forgot to mention that. Real quick, anyone that worked through this, give me a thumbs up if this is a solution. Give me a thumbs down if this is not a solution to the system. I see 1, 2, 1 up, 3 down, 4 down, 5, 6, 7 down. Okay, good. If you stopped after the first one, you probably said, yes, this is the solution to the system. But once you worked through the second equation, things might have changed. Let's take a look. In my first equation, 3 times 3 gives me what? 9. Bring down the 2, the minus, and the equals 7. What is 9 minus 2 going to give us? 7. Does 7 equal 7? Yes, it does. So this first statement is true. Let's move over to the second one now then. What does negative 2 times 3 give us? Negative 6. Good. What about 4 times 2? 8. Bring down the plus. Bring down the equals 3. What is negative 6 plus 8? Negative 6 plus 8 is what? 2. I heard a negative 2. Negative 6 plus 8, positive 2. Bring down the equals 3. Is 2 equal to 3? No. This one is false. So because one of these equations produce a false statement, that means this is not a solution. I'm just going to write here, not a solution. And that's the answer that I would like to see on our worksheet. Instead of just saying yes, no, when we look back on it in a week or two when we're taking our quiz on this unit, like I mentioned, we're not going to have a full-on test because this is super short, but instead we're going to have a quiz and a project. How fun is that? So I do want to see you say not a solution as opposed to just saying no. Yesterday it was fine, but today let's be a little bit more specific. If you get a true and a false, say not a solution. If you get a true and a true, just say is a solution or yes a solution. I don't know. Anything that indicates that you know we're talking about solutions, because that's going to come into play later. Questions I can answer about this second example here? Most of us got it.